So if you've never, like said, I really don't need flashcards or whatever, if there's ever a time that you draw flashcards and summarize this stuff, it might be for these three processes. So you got pressure, volume. So here's the main thing. This pressure can only exist in newtons per square meter, and that volume can only exist in cubic meters. And here's the reason why. It's because when you find that area,
R10 has opposite
and you
sides,
take
and
newtons
I have
per
a
meter squared
decrease for C instead of increase.
times cubic meters, you end up with newton meters, which is joules, which is work. So the area underneath this graph represents work, okay? So you're going to have three different things. You can have an isothermal line, okay, which means your change in temperature is going to equal to 0, which means your delta U is going to equal to 0, which means your Q plus your W have to add up to 0. So what that means on an isothermal expansion or contraction, whatever energy that you put into it is however much work that you do, or however much energy you take out of it, that's how much work was done on the system. So this is all about prepositions. So here's the main thing. If you look at this equation to calculate that work on an isothermal, which is nRT natural log VI over VF, here's the main thing, is that if that initial volume is smaller than your final volume, okay, that means that it expands, means you're taking the natural log of a value less than 1, which makes work a negative value, okay? So whenever a gas expands, you can say the gas expands, you can say that the gas does work on the environment, a couple of different ways that you can put it. But you got to understand the prepositions. So if this is expanding, then if you're going in this direction, work is going to be a negative number. And you use this equation here to find that area underneath that curve. Okay, now, there is another way to find work, and that's negative P delta V. So why can't I use work equals negative P delta V on an isothermal line?
Because it's V0? No. It would be...
Oh, because the pressure and the volume are changing.
Yeah, you're changing the pressure and the volume. I can't use negative P delta V because I don't know which pressure to use. Okay? Because the pressure is getting smaller. So basically what happens on an isothermal expansion, you would dump energy into the system, you would have a positive Q. So you would put this on a hot water bath, like Will and I just went over and started heating up water. Okay? So you would put this into a hot water bath. Energy would flow in. So here in about an hour and a half, I have to go over to Vermilion and read my children's book to the kindergarten class. So, huh?
That's where we're from.
Oh, you were Vermilion alumni?
Mm-hmm.
Okay. Never been in the building, so that'll be interesting. So, I'm going to dump energy into the system, okay? Positive Q. Instead of that increasing the temperature, it's going to take that and it's going to do work. So that's like me leaving Cohen $300,000 in my estate, but he has to spend all $300,000 of it to do work. Okay? He doesn't get to keep any of it. Expanding, boom, negative work. Q goes in, all that energy goes to do work. Now, you can also have an isobaric expansion. So this is isobaric. Now, on this one, you could do work equals negative P delta V because of the fact that you have a constant pressure. So work equals negative P delta V, and the only reason that negative sign lurks out there is because of the fact that that way the sign convention works. So if the volume is expanding And on that delta V side, you take V minus V naught. So if you're expanding, the final volume is bigger than the initial volume. So we put a negative sign out there to make that consistent, okay? Now, here's an interesting question. You have two ways to expand this gas. You can do an isobaric expansion, or you can do an isothermal expansion. In both situations, I go from 0.1 to 0.5, whatever the numbers are. In both situations, I have the exact same change in volume. Well, which one is more work? The isobaric or the isothermal?
Isobaric.
Why?
The area under the line's bigger.
Yeah, it's a bigger area underneath line, so it's more work to do an isobaric expansion than it is to do an isothermal expansion, okay? So if you're going in this direction, you have to, basically what's going to happen is that your delta U is going to be a positive number, mainly because of the fact that you have to increase the temperature as you're going across, okay? PV equals nRT. I'm keeping the same pressure, the volume's getting bigger. The only way that can happen is if you increase the temperature. So I have an increase in temperature, I have a positive delta U. That means that on this situation, my Q value here, my positive Q is greater than my negative work. That's the only way that I can generate a positive delta U value. All right, so the last thing you can do is isovolumetric, sometimes called isometric. So this one's simple because how much work is done?
Zero.
Zero, because there's no change in volume. So, but what makes isometric different than the other ones is that there's no change in volume. So with that one, you deal with that one with like closed systems. So like in the lab that you're going to do today, you're going to have parts where you have like a moving syringe. That's going to be isometric or isobaric, okay? Excuse me, isothermal or isobaric. The other part of one you're going to do where you have a closed, locked-in glass test tube where there can be no change in volume. If there's no change in volume, the only thing you can do is isovolumetric, okay? Cool. All right. On number 8, you should have to do 5 calculations. You warm the ice, you melt the ice, you warm the water, you boil the water, and then you warm the steam. So if all goes well, that answer to number 8 should be something times 10 to the 6th. I should do 5 different calculations. Now on number 1, so basically, and it's kind of a cool concept. So what I'm asking you on A is that how many joules are equivalent to 230 calories? Just a simple conversion. That should be something times 10 to the 5th. Okay? And then on B, I go, how many times could you lift a 50 kilogram mass to a height of 2 meters if 25% of the calories are available to do work? So that's typically what we have available. So your answer to 1B should be around 250. So if you could take and convert just the pure calories, 25% of them, into doing work, you could lift that about 250 times. Now, what I did on C, I said, okay,
That's so weird.
what if we
You also
convert
got-
all of that energy into the capacity to do work?
you also
How
got-
high could you lift a 70 kilogram person? So that answer to 1C
I just had to
should
think
be between 1,200 and 1,500 meters, which is about a mile. Okay?
From an almond joy.
From an almond joy.
Is that like,
If you could convert all of the energy that's stored in an almond joy,
Jeez. That's
Yeah.
pretty wild.
that's why I put that in there. Your
Makes me
answer
want
to
an
number
almond joy
3
if
should
it's
be
an
bigger
energy.
than your answer to number 2, but both of them should start with a 1. Your answer to number 5 should be bigger than your answer to number 6. And your answer to number 5 should be around 90.
For sure somehow I might get an A on it.
You say that, and then he grades it.
On number 16, the answer to A should be something times 10 to the 5th. The answer to B should be something times 10 to the 6th.
Can you say that again real quick?
A should be to the 5th.
On,
B
16.
should be to the 6th.
on which one?
Huh?
Which question?
16.
16. 1 6.
Mm-hmm.
What do you have?
Nothing.
Oh,
I couldn't
okay,
get that one.
cool.
I saw 16. Yeah.
On 18A, that's when you've got to use that work equals nRT natural log VI over VF.
So what did you?
And that answer to 18, this is just the absolute value. You decide if it's positive or negative. Should be between 250 and 300.
250 and 300. Oh, I'm not even close.
I'm just a little off.
Thank you. Yeah, but
I'm a little
I'm not
off.
even remote.
It's
Maybe I did that
250
wrong.
between 250 and 300.
Is what?
250 between 250 and 300.
It's not 250.
Dang it.
Oh, I don't think it's 492 either.
There's
Oh, God, no.
I got point.
you got
What?
9?
0.9.
Oh, my God.
Yeah.
Children.
Maybe I just
Hey,
did
hey,
math
hey,
wrong or
hey,
something. I
hey,
don't
You,
know.
Sean, you do not get to comment at all on anyone's answers.
The gas constant is 8.314, right?
Yes.
Okay, I just those out of my memory, so.
So you got 0.1 moles. You got 8.314 joules per mole Kelvin. Did you leave the temperature in Celsius?
Wait. Confused.
I'll take that as a yes.
What's 23 plus
Change in
273?
I refuse to answer that question.
Gershon, what's 23 plus 273?
296.
Oh, that's why. I just I did that in my head.
What
I didn't even walk
274.
Yes,
You took 273, added
Added
23 to
23.
it, got 274.
You
I'm
know, when you
confused.
say it
I
like
don't know what I
that.
did.
Yes, I say it like that. In my teacher voice, as my girlfriend calls it. She goes, don't talk to me in your teacher voice. I said, oh, I think I am.
How about negative 270?
Is that between 250 and 300?
I'd say so.
Seems about halfway.
Kids these days.
Oh, don't even start.
Probably-
Shut up, Cohen.
Going,
You
You haven't even done half the assignment.
I'm barely alive
It's
right now,
probably the
guys.
phone. That's probably why I got that wrong.
Okay, anything else? Once.
Wait. So, 15, C. So when work is, so when the gas does work, does that mean energy is flowing out of the system?
It costs it energy. That's just like when it expands.
Okay.
Like you're wrapped in saran wrap and you're fighting with saran wrap.
Okay.
So would it maybe be increase on C?
I don't know.
Am I right, Will?
Did the volume?
Okay,
Oh, it said did the
Read the
volume.
question.
I did that when I answered
No, read the first 4 words. What does it say?
Ideal
Expands.
gas.
it. Expands.
Hold on. Hold on.
Yeah, so then W is negative, so the...
I don't know what I read when I read C, but it was not the volume.
And could you give a hint?
Oh my God, Gapshon.
No, I don't want a gap. I just
Oh, what?
want...
Gap Colin?
It's not the same.
Doesn't roll off the
on
tongue.
16, what kind of deal is that?
What do you mean?
What are you talking about, alcohol?
I mean, because it's not. I don't think it's a. The way I read it, it was not like an ISO of anything. So
Oh, W equals negative P change in volume.
W.
That's what I did.
Yes.
I wrote that down on my paper. You see See, I have it written down.
So wait.
Can I see your 18 code?
Yep. It's just a line with the numbers in the formula, so.
Okay, anything else?
Mm.
Going once, going twice, sold. Okay,
Did
What you
not,
guys get
stop
on
you
the
on camera.
he did not want anything else.
I,
No.
I'm gonna look great.